On this example, we're given the second derivative of a function f of x, and we want to know a little bit of information about this. First of all, we want to find f double prime of 4. So to find that, what we can do is use our second derivative and plug in 4 in for each one of the x's. So 4 minus 3 times 4 minus 4 times 4 minus 1, which works out to be 1 times 0 times 3, which, because 0 is being multiplied by the rest of it, will give us 0. So what that tells us is that we have a potential inflection point occurring at an x value of 4. The other potential ones would be whenever these other factors would be set equal to 0. So we get x values at 3 for the first one, 4 for the second one, and positive 1 for that third one. So to determine whether these are actually inflection points or not, what I'm going to do is go ahead and place these values on a number line. So this splits up our number line into 4 different regions. What we're asked about is f of 4. So I'm really just concerning myself about these last two, between 3 and 4 and to the right of 4. So what I'm going to do is I'm going to check the concavity in each one of those sections, because second derivative always has to do with concavity. So to evaluate this, what I'm going to do is pick one value in between 3 and 4, and then one value to the right of 4. And I'm going to plug these into the second derivative. So as I evaluate at 3.5, I go 3.5 minus 3, and then 3.5 minus 4, and 3.5 minus 1. Now, all I care about is positive or negative for each one of these factors, because they're all being multiplied together. They're factors. So 3.5 minus 3 makes positive, 3.5 minus 4 is negative, and 3.5 minus 1 is again positive. So we have two positives and a negative multiplied together. What that tells us is that overall the result is going to be negative in that section. All right, when it's negative for our second derivative, that means it's going to be concave down in between 3 and 4. Next, we're going to pick some value to the right of 4. Let's pick 10. Any value we choose out there, whether it be 5, 6, 7, or 100, they'll all produce the same positive or negative result. So that's why I'm not really doing the evaluating and figuring exactly what number comes out. But plugging these in, we'll go 10 minus 3, 10 minus 4, and 10 minus 1. All right, positive, positive, positive. Sure, it's 7, 6, and 9 if you're keeping track, but it doesn't really matter. We have 3 positive values multiplied together. Overall, that's going to be positive in this section. So with positive for the second derivative, when you plug in that 10, that tells us the section between 4 and infinity is going to be concave up the whole way. And because our concavity changed from concave down to concave up, that tells us that x equals 4 will be an inflection point. That's probably the wrong vocabulary to say there. An x value of 4 will be where the inflection point is. That'll be the x value for the inflection point. We would need to know more information about the original function f of x in order to find the y value to go along with that x value. So I hope this helps out as you're trying to understand what the second derivative tells us about the original function. Good luck.